Hey, John.
Hi, good morning.
How are you?
Good. I've got my slides.
All right.
I've got a presentation, I don't know, about 26 slides.
So, what kind of input do you need? HDMI or?
Well, I don't know. I'm wondering if I can use
What is your laptop?
project your computer.
Oh, you want to use my computer? Okay.
Well, maybe you're set up. And it's not going to be all that long. Got this. Oops. I don't know if you want to use it, but I figure I'm not going to be long. I may be 10, 15 minutes.
You want me to run it and you just tell me when to advance the slide? Yeah, I can do that.
If you like. That might be good. All right, it's the one and only PowerPoint.
Okay.
There are other slides on there. Excuse me, there are other images on there.
Six circuit boards?
Yes, that's
Okay.
it.
How have you been?
Oh, I've been out of doors, doing outdoor work, and then I've been doing shuttle work with hot wings, chicken wings, and that's both Saturdays and Sunday evenings.
Mm-hmm.
And I'm very glad that the temperature's finally going down.
Yeah.
Take this space.
No, help yourself.
And then I wanted to move on eventually to typing in text and have it displayed. You can scroll right, scroll left, and just flash.
Mark, I think I missed the
which,
You know, I sort of, at one point I said, well, I'm gonna do this as a hobby now forever. And got all fired up, and then it's spent most of its time idle since then. So, yeah, with the little screen. And we got a Bluetooth key. Just threw this in the bag this weekend. I had intended to fire it up during the week in preparation, but again, best plans did not. I wonder if this even has a battery in it. No, if it does, it's rechargeable. Charger's probably gone away. Who said, what was your name again?
oh, John.
Jones? Okay. You from around here?
I'm at Belvoir. Belvoir's going right down Route 1.
Yeah, I always think, you know, Mark, I always think it takes a half an hour to get here for some reason, and it's like 7 minutes away. You know, I'm coming from Hope One over there, right? It just seems like everything is half an hour away from my house.
Well, there's probably truth to that. You're probably thinking weekdays.
Ah, that's true.
Weekends, you breeze around like, because there's no traffic. Especially on Sundays, but yeah. Saturdays, as the day goes on, it's going to get, that road Blackburn tends to back up.
Is that me right now? There's a few second delay on it, right?
Yeah, I keep going back and forth between the slides and the camera because I figure break up the monotony a little bit so people viewing remotely will get to see our smiling faces from time to time.
Do you have a lot of remote calling? No?
Well, there was one guy, well, actually two guys that canceled at the last minute. They said something came up, so I said, all right, I'll live stream it.
One cable short than what I need.
So you still CISOing?
I'm still CISOing. In fact, that's one of the reasons I've sort of backed off on the meetups that I do attend is because my world has changed quite a bit. I was doing about 50% application development and the rest was CISO related. And now, what am I doing now? Now I am my big projects right now are privacy procedures and controlled unclassified information procedures. It's just killing me. I hate it, but it's all.
Do you have any staff working under you?
No, we're about a 50-person agency, so it's very comfortable normally. We get to sort of do whatever we want to, but we have to do everything, right? So so the annual FSMA report is due, and we've got to make improvements. We get audited pretty regularly, and there's things we have to attend to. And I just can't believe, I don't know how government-oriented you are, but I did not realize until a couple of weeks ago that the government has decided, the sensitive, eyes-only classifications and things like that are all being replaced with this controlled unclassified information system. So, yesterday I finally got from the National Archives how we're supposed to mark emails. I'm not sure how we're going to do this. They have to have headers on all emails in the subject line and then across the top of the stinking email. And if you forward it to somebody, you have to copy the header from the forwarded message into the header on the new message. And all your information has to be classified as to what category of controlled but unclassified information it is. And then, so you've got this marking. I'm sure it's it's kind of, they have, so you have CUI, and then you're supposed to put // and then a category for what type of information it is, so if it's procurement information or whatever. And then another / and a distribution code of some kind, like, you know, agency only or board members only or something like that. So they've got a whole little syntax to these things, which is not necessarily, it's sort of half human readable. Right? And it's dictated to every agency in the government, except for the DOD. You know, and apparently everyone's been sort of dragging their feet doing it, but it's caught up to us.
Is this part of, you know, annual updates to E570?
I'm not sure I know what an 8570 is.
Oh, I don't know. That's the, I don't know specifically, but that's supposedly at least a few years ago, it was a standard for just keeping track of better layers of protection to keep information confidential, especially big things.
Well, no, I don't think so. So it appears right now that there are at least 4 different policies that apply to information. There's the standard FISMA policy, you know, the security policy. And then there's a separate privacy review. And then there's this controlled but unclassified review. And then there's a records categorization, right? So it appears that every bit of information your agency has to be classified under these 4 different policies. So you do a risk assessment to see what kind of FISMA category. Well, first off, you have to inventory what information you have, right? Which is a big assumption that anybody knows what it is, right? So that you got to do a lot of work just to find out what all the information is, who's hiding what where. And then you've got to say, okay, so is this, what is the security level of this information? And then you should do privacy, right, which is separate. And privacy apparently can only increase controls, it cannot decrease controls. So you get base controls from security, then you increase them if there's a privacy implication. And then you have to decide whether or not it's a record and of what type, what category it falls into. And then if it's not classified, which means, you know, I'm not quite sure what they're doing. You know, it's national security, it's not stamped classified, it's just normal information. Is it controlled or not controlled, and if controlled, how? It's going to be great. It's all just paperwork. You know, I didn't want to be a lawyer, I wanted to. I wanted to play with machines.
Be a tech person.
I wanted to be a tech person, not whatever this monster is. So I've got like a direct connector on my USB cord, and it's doubtful that I have anything like it. Okay. Yeah. Let's see if it lights up at least, and then I'll put it back away. Good. Come on. There you go. Oh no. It's upside down. Oh, that's interesting. When he's booting, he would love to see a keyboard eventually. It's got Raspberry on it. Raspberry Pi. Yeah, it's ready to go if there was an input device. Oh no. Oh, that's not good. I wonder what's happening. Well, shut it down. This is going to be dealt with slowly at home, I can tell. I wrote a trail camera program for this. That's my only accomplishment with the Raspberry Pi. I was using in Node.js. I used the OpenCV, which is the image processing open source program, because I was dissatisfied with my trail program. My trail cameras, they weren't detecting motion as well as I thought they might. So I did basically I was taking photographs every 10 seconds, or you could input the duration, but then it would do a comparison, pixel by pixel between the two. And it would add up the differences. And if the sum of the differences exceeded a threshold, then it would say, motion, save that image to memory. And it was kind of fun. It caught a lot of changes in light and, you know, other things like that. But it would also catch a squirrel running across in front of my camera. And that's where that was. So I had the little camera hooked up to it. But after that, and that's where the project died, probably a year ago, something like that. That was kind of fun. There's I'd like to see. Well, the problem with trail cameras is they use these infrared motion detectors, which my understanding is that a typical trail camera will have about 64 sensors that are picking up infrared radiation, and they're like a fan signal, and they're directional, but they fan out in a circle. So what they're looking for is a change in infrared signal as it traverses horizontally. Right? So sometimes they pick up a deer at night, and sometimes they don't. Right? But it would seem, but you're not going to pick up, if you were a human being watching it, you know, you're going to see antlers moving in the trees way in the background somewhere, right? And I took some trail camera pictures that had deer partially exposed and ran it through Google's image analyzing cloud service. And they couldn't figure out that was a deer. You know, they would often, you know, it comes back with a JSON object that has, you know, it says like it's trees and it's forest and, you know, stuff like that. And then it will say something like, if it figured out that there was an animal there at all, it would say mammal possibility 60%. And then it would usually default to something totally wrong, like maybe it's a dog. You know, say no. I know what that is. You know, when I look at this image, I know what it is. So there was some fantasy about collecting a large number of images and training an AI thing to just recognize deer. Right? But that's beyond the scope of my current time. My allowance. You know, because if you're, I don't know if you guys are doing deer hunting or not, but if you're watching for deer, the idea is to see them before they see you. Right, and you're typically looking for very obscure things like their nose or something that's out of shape, because it's all, you know, they're in the bush, they're behind trees, so you can pick up motion pretty well, right? And particularly in the wintertime when there's a white background with just a bunch of vertical lines, then it's kind of easy to see them way off there. But in the fall, they're very, and, you know, something like a face, you know, so you almost want to do like deer facial recognition, or I'm thinking maybe antlers would show up. I don't know.
Hey, man.
Too much fun.
Hi, everyone.
Hey.
That's just my cell phone. I got a new smartphone.
Well, I've got a few minutes after 10 if you want to
Yeah, should I get started?
get started. Just let me know when you want me to advance
You want me
this.
to stand? Stand up?
Whatever you want to do. You've got the floor. Whatever you want to do.
Okay. Am I on camera too? Doesn't have to, I don't have to be, but I'm just wondering, should I talk into the camera? Or just,
No, the camera's actually aimed at your content on the tabletop.
Hi.
Morning.
Did I see you up in Tyson's corner?
Yeah.
Okay.
Welcome to Woodbridge. Where are you coming from?
I'm coming from work, so I'm like centered between the
Good.
two. Yeah,
Not too bad.
This is the first time I've been to the Woodbridge. Cool.
We're just about to get started on Arduino and Raspberry Pi.
Interesting topic. I definitely had to come to this one. I definitely have been thinking about buying some Arduinos because I want to start working on them. It'd be good. Yeah.
How you been?
Yeah,
It's been a while, huh?
yeah.
Long summer.
Is it okay if you, once everyone's done and the group's over, I can take a gallon of orange juice home with me?
You certainly may.
Oh, thank you.
I declared to my wife I was going to violate her diet when I got here. And I know Mark is always that dumb. And that says all rules are off. I'm off the wagon.
But she allows that, right?
My wife has got very low, what do you call it? Delay of gratification. So, which always made her a fun date, but not good for other things.
All right, I'll wait till the other two get back.
Okay.
Right? It's,
I think it's just him. I think that other gentleman floating around has something to do with the church. I don't think he's part of us.
oh, okay.
Excuse me, Mark. It's been a while since I got a new laptop, so could you please tell me the Wi-Fi?
Oh, it's can you see it up there on the wall?
Oh, yeah, I can. Thank you.
So yeah, there's the Wi-Fi taped up on the wall.
Okay.
I don't think you'll need it, but if you want to go online.
Sure.
David, I'm Dean.
Nice to meet you. All right, go to this one and the faces one.
That's what, next week, right?
Yeah. I also recently passed the Linux Plus certification.
Congratulations.
The old one, the new one, they're moving in afterwards. So. And got my foot in the door.
My name's John Wilson, and I'm going to give a 26-slide, PowerPoint slide presentation on my work, more likely attempts to get as many as 6 different circuit boards up and running with a loaded operating system via SD card, and also add an attachment of a visual display so that I can scroll text. And I was just interested in YouTube videos and how quick and direct the YouTube video instructors were, as well as some of the advertisements when you walk into a micro center there out there in Merrifield. The parts, and it just seems to be, well, you can just add the parts together quickly assemble the circuit board and use it as a demonstration for your teenager or for another adult.
That's the dream, right?
Yeah, and kind of plug and play, kind of like a tinker board, tinker toy approach that, or the metal toy that was when I was growing up called the erector set. With that. And I found here, and here's what's displaying it on my first slide, that in order to get the Linux or Android operating system downloaded and onto that SD card, I needed more than just one or two of the YouTube slides to do it. And I had to learn some terminology about formatting the SD card, partitioning the card, and then etching. And at least I was able to identify those 3 steps. And I want to volunteer that some of the more current software includes all 3 steps in the execution of the icons. Before, sometimes you needed 2 or even 3 icons. And when I say before, this is 2010, 2012. But I have some of the icons on display just following this slide. And the second item, let's see. Let's go back. Let's go back to the first one if we can. And the second objective was a start screen to work with the devices. And I was finding out that the products that I bought from the Micro Center, when they came in the boxes, they didn't have instructions with them. And I would attach it to both any one of these 6 types. And even with a working and loaded operating system, the light would come on in the display devices. And I want to say that I got over that with some consulting help that I had to pay for. But I found that more reliable display devices were like this, 5 and 7-inch Raspberry Pi display devices. It did work for me.
And John, is all of this available at Micro Center?
Yes, yeah.
You've got a lot of stuff up there. Here I want to say, this is my bottom line up front, and I want to present, a couple of concepts, what I was trying to do, and how far I got, all in the first slide, my bottom line, straight up. And I'm saying that with that consulting help, I was able to get Linux Monero, Linux Debian, and Android to load into the Raspberry Pi, into the Tinker board, which is a similar architecture board, the Raspberry Pi. And I was able to scroll on the Android as it was attached to my laptop. My other devices, like the Galileo board, which I really like, and is now discontinued. It's no longer manufactured by Intel, and it's no longer sold by Rakuten. So I just have the one final board here. I was able to get the display lights to come on, the blue light to come on, but it took a heck of a lot, and I stopped right there. I never did really get the experiment with the display device. My other device that I was interested in and sold at Micro Center is this TI MSP 430, which is a very small board. And I think TI decided they're going to have a display, an educational board manufactured for young kids and hobbyists. And I found out that it really doesn't do much. It's not going to serve my purpose, which is scrolling characters. Yeah. But I kind of got the idea that TI does have a lot of software behind it, and it's worth looking into to see if you would like to either download or modify software for ARM, circuit boards, and Wi-Fi applications.
So within your experience, I mean, it seems like the Raspberry Pi has got market dominance in this fair to say, right?
Well, I was wondering why Intel would still be fazed by it, because I would think Intel would want to put a product out there, at least get some hobbyists interested in it, and develop it from there. You're right. You say the market dominance between the Raspberry Pi and the Android is simply a secondary device. But I'm just interested. I don't know why Intel dropped it.
No, I had some friends who worked with Beagle boards for a while, and I'm not even sure who makes those, but I think that's all gone, that's faded into history now also. So it just seems like Raspberry Pi is the only game in town.
Last time I was up at Microsoft, which was a couple months ago, there were still Beagle boards being sold.
That's right. There's another one, Pico. Does that sound familiar? Maybe I'm just making this up. Yeah. Okay.
So I have a question. So is Arduino also ARM circuitry?
I don't believe it is.
I don't think so.
So in order to get them to talk, there has to be some kind of compatibility.
I mean, there's a lot of ways to get devices to talk to one another.
Because you were doing a use case where you had like Raspberry Pi sort of in the center that has more capability than sort of an Arduino. So Arduino can do things simple tasks. I don't know, I've never worked with Arduino. I don't know how it's about, how to define it. But my understanding is like what you were trying to do is you had like Raspberry Pi in the center, and you had like multiple Arduinos, and they were kind of talking and doing the task.
And you've seen that?
I've heard examples like someone will make a garage door opener or something, I don't even know. Their Arduino will be the thing that actually will open and stop and close, but the Raspberry Pi will do more, will be able to run programs and so on, activate those.
The processor on the Arduino, my understanding is that it's much slower clock speed. It's like 2 orders of magnitude slower.
I see.
It's huge, and it doesn't have a Linux operating system. It boots up and runs this processing, a language called processing. I think it's called a processor.
I don't know. This is new.
Yeah, it's a respectable language, but it's not Linux. So and the other thing that used to have as a huge advantage was it was inexpensive, but now they're all inexpensive, right? So my gut feeling is that because the Arduino is much more hardware-based, that it might be able to handle some hostile environments better. But the Pis are just really rock solid now. Some of the other processors are very strong. They're running full-blown Linux. So, geez, it seems like that's the way to go. They've got, what is that Raspberry Pi that's so cheap? They've got like a $5 or $10 board, which would seem to negate the applicability of Arduinos. I'm not sure. In other words, if you're going to make a device, right, you've got a power supply, you've got a case, and you're going to spend as much on the case as you are on the processing board a lot of times.
Well, what about like a use case where you have to reduce the power consumption? Would Arduino be better for
That's a good question, yeah. I don't know.
That's
That's a good question. Geez, I don't know, but some of the...
some people make little robots.
Yeah, but I mean, the little tiny Pis, I'll bet they run pretty well. Not sure, right?
I'll kind of pull it together again, and then we'll move on to the slides. The six types of circuit boards that I've talked about. I mentioned 5 already. The sixth one, which I was very attracted to from the suggestion here at this session, was the Raspberry Pi Kano, also manufactured out of England. I believe it's a subsidiary of Cambridge University. And I have it here, and I was glad to get to learn that even that it's supposed to be simple enough to assemble for a 6-year-old. And here I want to show you in the back how easy it is.
Nice colors.
Color connected, and the software does come up, and it's kind of interesting for a child, the options that appear. I've tried to download the Arduino software on it, and it does download, but I was not able to find the installation of it. And so that's something I'll keep in mind over the next few months. I'll try to get Arduino software installed on this and figure out why the operating system won't let me. And there is an addendum to this keynote. There's also a kit called PyTop that's very similar to the keynote. And I haven't purchased it, so I don't have it here on display, but that's supposedly is simple enough for a teenager to use the Raspberry Pi again. And it comes in a plastic green case, and it's supposed to be simple enough for a teenager to download the Linux software and then install the Arduino C code for an application. So that's it. 1, 2, 3, 4, 5, 6. I've got 3 versions of Raspberry Pi, and then I've got the 3 auxiliary or separate architectures here on the left. And I thought, well, you know, spread out my interest in the boards that I would be able to get the systems to load quickly. And I was able to get some success with the Raspberry Pi, as I said before. Keynote started up right away. I was able to substitute the Tinkerboard, and the Tinkerboard advantages is that they're color-coded pins on the side that are not on the Raspberry Pi. And then also success I had, I was able to scroll with the Arduino boards by adding a display device and scroll characters right and left. Okay, that was my bottom line up front, my objectives. 26 slides. I'm not going to bore you, I hope, and I'm not going to give you too much. So let's go on to slide number 2.
Nothing about Linux or Raspberry Pi to be boring. You're amongst friends here.
Item 1, I'm talking about formatting, partitioning, and then etching steps. I was talking about display screens that I was buying inexpensively at Micro Center. And the third point I want to make is that I've been working on this, I guess, over the past 2 years. And I was hoping to quickly get a resolution from this and also be able to explain it to people like yourselves or kids at my church. And I'm just kind of disappointed that I ran into difficulties. But that's not to say that I can't get past them with some help. Not necessarily here, but like I said, I paid a subcontractor to help me with the screens, and there are some people I have contact with at the church who will give me some tips.
I'm looking at you as the expert here. Don't expect any help.
Okay. Well, I want to say my approach was kind of spread out at different. I would think most people would just buy 1 or 2 approaches. I'm a Raspberry Pi person or an Arduino person, or.
I mean, I've got a Pi, and it just boots up to an OS, and like any other Linux. But I haven't learned to do cool things with it, like cameras and that kind of stuff. What it's really meant to do.
Okay, so I also want to put my final point that a lot of these projects leave out estimate of time and money, and I'm sure any hobbyist want to keep that in the back of their mind, and I'm sure professional organizations, large companies, and the federal government, there are people there who spend a lot of time keeping track of the amount of time and money that are paid to people to keep the information systems up and running. And you know that from experience. I know that from my Army experience. And I'm just, for the future, I guess I'm looking to see if anybody will make a YouTube video.
I'm guessing they're out there.
Somewhere, sometime in some place, somewhere in the world, someone will make a YouTube video that gives time and money estimates. Okay, let's move on to the next slide. Those are 3 items that I wanted to get into: format, partition, and etch, unzip Linux OS onto an SD card. Those 2 slides dealt with, the first one dealt with, I think, partitioning, and this is the current, partitioning, and that's from a couple of years ago. And then I've got these 2 available: Balena Etcher, Win32 Disk Imager. And in this case, the formatting and partitioning is included in this software. And it takes about 20 minutes, 20 minutes to do the whole process to get it on the SD card. Okay. Here is the Arduino icon that lets you access to the Internet C code. That's what it looks like. I had an option for the pop-out scroll message of all the C code, short C code programs that are available, but because of the viewer, it doesn't let me do a snip image on it. But so I'm kind of missing a step. There's a step in there that will show the programs that you could go to. So I went to the next step in it, and this is my test for Google Crystal Display. And this slide and the next 2 slides just give you a view of what's available there, and it's very readable, and it's kind of neat that you can get a view of description of the code in English, who wrote and modified the code, and this last one is the actual C code itself. Well, I think there's one after this, I think.
No.
No? All right. Now we move on to my types of circuit boards, and we discussed that in the past 10 minutes, so we'll just zip through these pretty quick. Let's just step through this.
There's your color-coded.
Color-coded Kano, Raspberry Pi, also coming from England.
But these are all available off the shelf at Microsoft?
Yes, and they're reasonable price. They're about $250 to $300. I don't have the Pi top, but I recommend it for teenagers. This is the 3rd one, the Tinker board. 4th one, these are my Arduino boards, and the one up at the top left. This is the one that's the original manufactured in Italy, with that kind of infinity bent over figure 8. And I also don't have up there, but I may have it on the next slide, but I have what they call the shields. The shields on top of that. And they can do things like graphics or audio, and in this case, the amount of current flow will turn on one of the 3 lights. Okay. This is what I came across. These are in this book here, the job script book. These are the options that are available for for additional C code. And I'm kind of interested in that, but I admit I don't know very much about it, of how JavaScript runs on your Arduino. And I was a bit surprised to find that about 2 months ago, that the JavaScript as opposed to C code.
Somebody's written a JavaScript interpreter that runs on there, right? So you must have to install that first, and then you can run JavaScript files.
Okay, the next slide, the one that's kind of dirty with a dark. Let's go back.
You want to go back?
Yeah. Well, maybe I dropped it off. I don't know. But there was another slide there that showed where to go to download the JavaScript, and I was unable to find it looking in the file. So that's a question that I have still, as opposed to a statement or a definite answer. But I'm going to try and find out in the next month or two how to download the JavaScript. The first icon that I showed you with the Arduino, that one has C code. And it's kind of set up in a display like this with pop-up lists. But I need to find out how the JavaScript works. Okay, let's go on. That's it. Those are the red, green, blue lights that display the amount of current flowing through the Arduino, and they can be adjusted. And, next one is the Intel Galileo circuit board. That was really my first purchase of circuit boards. The advantage that the Intel Galileo circuit board has is it's got more than one processor, so it has parallelism. It can run more than one operation at a time. That's why I was interested.
What was the release date of Galileo, and when was it discontinued?
I think it was discontinued last year, about summertime.
When was it released?
Probably 4 years before that.
Or is that interesting?
All right. And that's my last one, the Texas Instruments circuit board. That I figured it doesn't do very much for me with LEDs. It's got a flashing LED sideboard, but I'm disappointed it doesn't let me type in characters and attach a display device and let me scroll characters. Okay, let's after this. Oh yeah, and I wanted to say a central part of all of that is a decent sized keyboard so that I can type in text. This is not too small, but it's just about right size for the fingers. And then once I get the text in to any of the 6, the idea was any of the 5 circuit boards, because this is not working for me, I can disconnect the keyboard and just let it run by itself. Okay, what's next? Those are examples of LEDs that I bought at Micro Center that don't power on. And there's a big question, why don't they power on?
Do you have a used part sale?
Yeah, $15, $20 each.
Yeah.
And I believe they're manufactured in China, Shenzhen province. And I was just struggling over the quandary of why they don't work. And I think they do work in special selected situations. But with my devices, I just don't have the right configuration. And maybe that's a too simplistic conclusion.
Are they
I wish I
current
had more
sensitive like the
details.
earlier one you mentioned?
Excuse
Are
me?
they current sensitive like the earlier one you mentioned? A specific current turns them on.
Possibly. Yeah, I'm thinking that's it. And I'd be interested in having somebody help me or work with it, but I can also go to my consultant up there at Tyson's. But I have to pay him $300 for a shop to do that. And yeah, go ahead.
So these are functioning properly, but they're not powered on because they have to have a certain condition in order to power one. Is that what condition is that?
Both for like voltage average.
Really, I see. So you run into issues with that if you have. Are they designed for like a specific kind of board, but not another kind of board?
It doesn't say. When I purchased them in the black box that they come into, there's no documentation.
Documentation at all.
That's been disappointing. That would be nice if there was some simple documentation.
You gotta find it where it was
Actually, now that I think about it, that's a good reason to use the Arduino. The input-output pins, the output pins have much more current capacity. So you can drive TTL devices directly from an Arduino. But you can't you need a separate output board if you're going to do it from a Raspberry Pi.
I see. So a few questions there. First of all, when you say TTL, what is that again? Remind me.
Transistor
Logic
logic.
categorization. It's a certain, it's a on is 5 volts. It has a certain current capacity.
I see. So that is a standard.
It's a standard. Yeah.
Okay.
So you can drive a transistor with a TTL output, for instance.
So the second thing I'm thinking is like a use case where you are controlling like an electric motor, and so with the Raspberry Pi you will need that, and then this output box, and then the electric motor with an Arduino. You can just go directly.
No, you would.
Well,
I don't know. There's some pins on the Arduino that I think have adequate for very small.
For some
motors, yeah. But for instance, I believe these boards with the LED lights on them are driver boards. Here, so you turn on these lights, but it's also driving. That's a big honking big transistor there, right?
Yeah.
So you can really drive current through that. So if you had a big electric motor, you could drive it on this board, and that's why it has this terminal strip for big wire.
So some of these are different standards, or like they're all like everything tries to go to TTL when we talk about like small electric motors. Everything tries to go to a certain kind of voltage.
Yeah.
Because we don't really need to have a lot of power. We just need to have accuracy. Oh, I see. Okay.
Yeah, no, this is news to me. I'm used to binary on-off 5 volt 0 ground.
Well,
I've never gave much consideration to current.
You can also get relay boards, which are even, that they have mechanical relays on them. So you'll go from a Pi or from an Arduino to this board, and it's got a driver transistor, whatever's necessary, to then fire a mechanical relay, and you can run the house current through.
Okay.
Right? But, so really the input, and then so your inputs are keyboards primarily, right? And then the outputs, it's whatever you're going to drive. And if you're going to turn on a garage door opener, you better have a relay board.
Yeah, when you say a mechanical relay board, you're talking, what is that?
A mechanical relay sends a pretty large current, larger than what the computers can put out. So you need a separate driver transistor through a magnetic coil inside of the relay, and it actually pulls metal contacts together. So it's like a finger flipping a switch.
I see.
So you can put some pretty massive current through those.
Yeah.
So yeah. And so if you're going to drive lights you could probably do with these transistors, but if you're going to drive if you're going to flip house current, so if you wanted to build something that you could talk to your Wi-Fi down to your Raspberry Pi board and have it turn on a light in your living room, you should probably be thinking mechanical relay as opposed to a transistor. Right? Because once mechanical relays are made, the resistance is essentially zero, and there's very little heat generation, right? But these have a certain amount of loss in them, so they'll sit there and cook all the time. So just for safety's sake, you want to go with the mechanical. But you can drive like LEDs directly off of the Arduino's output pins. Right, so that's very low current, but that's sort of a TTL level current is enough to drive one of these little LEDs, right?
Yeah.
You could not do that with a Raspberry Pi. You need a separate, I think.
Gives me some little, this is good. As you write this, I'll make a little network system diagram of this. That'd be great. Thank you.
Yeah, I don't, the point being, have you seen them? I think I have one of those little tiny ones here.
I should have brought, I brought my standard input was like a little cheap, like Chinese keyboard that you just, it's like it's meant for a tablet. And I just flipped it up, attached to the Pi, got like a touchscreen display, which I never really use because unless you have some sort of program where you would do like, let's say like you have like a temperature monitor, that's great for a touchscreen. But I never used it, so then I just plugged it in and I had like a little keyboard and a mouse. Because I'm trying to set up a home server, that's my project right now.
This thing is this is a Raspberry Pi too, right? And I think it's under $10.
That's the time, yeah.
Yeah, the little tiny one, but it's got an HDMI port,
No.
right?
Wow.
That's amazing. It's got power, it's got a USB port, it's got a little microchip socket, so you can load up your operating system and stick it in there. Now this obviously doesn't got the power to drive anything.
No.
Right?
But with mechanical relay.
But if you have to go to another board, so I guess my point being, Arduino is what, $15 or something? This is about $10, right? So if the Arduino can drive it by itself, maybe that's the better solution. But if you need a separate driver board for either one, then suddenly the costs are the same.
I wonder, have any of you ever hooked up a Raspberry? I'm sorry to interrupt. Just let me.
No, I don't think.
Have any of you ever hooked up a Raspberry Pi to a battery rather than like plugging it into an outlet?
Oh, yeah.
And what do you think of it? Does it last a long time?
Yeah, that's a long time. That's a real long time.
I don't know. You probably already get some interested in like robotics.
Well, so this is, and I apologize too, but this was one of my little Raspberry Pi setups. And the way that I powered it was with just a big battery. But I forgot, I don't have all the cables. So I brought this, any sort of USB power supply battery will do just fine.
Okay, cool.
And you plug it into the USB. There's a USB port that I believe is dedicated for power. I'm not sure. Plug it in there and off it runs. Yeah.
Well, I'm nearly done. These are right there, LEDs that do display text that have the pins are manufactured with industrial soldering connection. And I would recommend, this is my advice, for kids and maybe young adults to stay away from soldering unless they can make sure that they can keep the solder off of adjacent pins. It's kind of hard. I've done that at Isaac Square, where I've attached the pins, and I found that I have to really try hard to make sure that the solder does not attach to two pins. Whereas if you spend an extra $10, between $20 and $25, you get one that's manufactured with solder. Save yourself a lot of time, just a little bit more money. Let's see the next slides. Okay, here's my list of publishing books that I'm relying on to get information from, and there are maybe about 8 to 10. Okay, I guess that's what I should have at the very beginning. Let's move beyond that. Okay, and these are the books that are sold at Micro Center that are introductory books that are kind of interesting, but again, they don't tell you how long it's going to take or prices for additional hardware to attach. Let's just zip through this. That's the Arduino soldering
You were just talking
example
about
that I was just talking about that you can do yourself, but it's kind of difficult. Arduino projects. Arduino installation on an SD card, and I thought that was very important to read and understand.
that one didn't help you with your earlier issue of not getting it to execute?
No, I was looking for a little bit more detail, and it's maybe a couple of years old to find the right etching software icon. Let's move on. And here's a display. Here's a chapter on display screens for the Arduino. That's kind of interesting. Here's another book. It's a smaller book of interesting projects for the Arduino. It's taught as Arduino 101, the first book on Arduino. I don't know about that. I found it very difficult to understand, and I didn't get any of the applications in that book to work. Let's move on. Next slide.
Thanks for the feedback.
There's the Intel Galileo book that is now not supported. And the next one is FPG, Field Programmable Gate Assemblies, that is related to the Galileo. Gate Assemblies, Gate Array. And then there's Linux for Raspberry Pi, that has the installation on it. And what's next after that? The JavaScript with the Fermata option. Okay, what's after that? And there's the display of the pop-up screen. Pop Resin is the place to go, resin.io. Next slide. Yeah, that's the dirty image, but I was not able to find resin.io on the internet.
Was Fermata interpreter? I missed something. JavaScript.
I'm guessing Fermata is a JavaScript interpreter.
Okay.
Would be my guess.
That's it, John.
I wasn't conclusive on that. I think that's the last slide.
Yep.
Okay. So, to wrap up real quickly, and not to overwhelm you with information, but I had as many as 6 different circuit boards. I had to go through books on downloading things onto the SD card, and finally I found an entry program that lets me do that, first step. And I had at least three of these circuit boards that would take the SD card and actually load the operating system. And then I guess the problem I had was with display devices. And I wanted to say that there are good display devices that will let me attach string of characters, and let me scroll right to left. But again, it took me several months just to get that to work. And so the conclusion from those 2 major points is that just kind of be aware of how much money you want to spend, and try not to get too frustrated. And I found out that you probably have to ask other people how to get over some of the difficulties of that, and not just depend upon YouTube videos. That's it.
Cool.
Thanks for your attention.
Where are you going to go with it now? What's the next step for you?
I'm going to try and find. Well, I have working scrolling display devices. I've got a 7-inch. There's one that's a 5-inch for the Raspberry Pi, and I'm going to try and maybe bring and show you the start screen for the different Linux versions. The Linaro for Debian. There's a command line versus the interactive screen for Linux, and then the fourth one, I guess, is the Android. And I just want to get to the start screen and be able to show that you can use your finger or a stylus on the screen to pop through some of the screen options. That's what's interesting, and that's why people are interested in getting a working version of these circuit boards. And I'll spend a lot less time, but I'll tell you some of my results in the next 2 months, 2 to 3 months.
So the whole objective of this, just so I understand, is you want to get, because I've seen Linux on the Raspberry Pi, there's distribution, but you want to get it on you want to get it on circuit board memory. Am I mistaken? I don't know.
Well, I used to like some of these, especially the
And on some of those.
Galileo, I can't do it on TI MSP430.
This is something that as far as your research, no one has done. They've supported Linux for Raspberry Pi, but not for these small other products.
Yeah, you're telling me that Linux doesn't really load onto the Arduino's.
Yeah, I don't think the Arduino runs Linux at all. It may have some kind of mimicking of Linux, but the basic system in the Arduino is this. It's sort of like the old Apple IIs that would fire up and then run basic programs. So the Arduino fires up and it runs programs in this language called processing, and then you can mimic other languages in that, right? So it doesn't actually run Linux as such. The BeagleBoard will, the Galileo will, and the Raspberry Pis do. Right? But the Arduino is more like a microcontroller, a programmable microcontroller, right?
So you said they had a lower clock speed, so they have all the components that a Raspberry Pi would, and all the architecture, maybe not the ARM architecture, but Linux requires like a certain clock speed, certain types of hardware support. I don't know like hardware, but you're saying Linux requires that. So as far as the architecture of it being like ARM, I don't know what Linux.
I don't think Arduino is an ARM chip at all.
Okay, yeah, because if Linux requires ARM, then of course it wouldn't work on the Arduino if Arduino is not ARM. But you know, that's why, you know, it would, if you're saying it would have a little difficulty. But it could, but in theory, well, what I was trying to say is in theory, if Linux does not require ARM and can run on whatever Arduino is and can just run on a slower clock speed, then in theory you could work on the Arduino.
Well, theoretically, of course, Linux did not originally run on ARM chips either, right? Someone had to write a kernel, a Linux kernel, that ran on the ARM chip,
Yeah.
right? So you could, in theory, write a Linux kernel that runs on Arduino, but my question would be, why? You know, I'm not sure why anyone would do that, right? Because, for instance, you know, Linux has a lot of different modules that it runs, right? And a lot of operating system overhead that it does. And if you've got a very small processor that is running at a low clock speed, that doesn't have the kind of brain power of the ARM chip, then it would be sitting there trying to do operating system functions all the time. Right? It's designed so that you can load a program directly onto it. Right? And it's basically got the operating system in hardware inside the chip. And that operating system runs the programs that you input into it. Right? So you put the programs on the, they have an SD card, don't they? There, yeah. Or do you download it directly into the chip? No, you put it right into it. So I had an Arduino years ago, and I would SSH into it from my laptop. And the program we had up on the screen is a program that packages little programs to load onto the chip. I think once you load them, maybe it's got sort of persistent firmware, because you can turn them on and off and the program still exists, isn't that right?
Yes.
Yeah.
That's.
So you use a laptop to write the program, and then it loads it into the Arduino for you, into a firmware situation, and then when it boots up, it will run that program again.
What's the connection into there? You know, what is the actual portable connection?
I think it's got an Ethernet or a USB connection. Yeah.
So you shoot it into there.
Yeah. Yeah. So if you're already a Linux person, then you should probably abandon Arduino.
Yeah. Well, and when you mentioned that it would just spend its whole life trying to keep up with the operating system. The operating system is doing continuous monitoring, That's why it's like bare minimum RAM we need for this operating system because it's constantly doing cycles and stuff. So that would just be far too heavy for an Arduino, like I said.
Yeah.
Yeah. Makes sense.
So it's already got an excellent Arduino system burned into the chip.
Yeah.
So for its purposes, it does very well.
Yeah.
But if you want to, I think if you want, you know, then it's fun to program in JavaScript on an Arduino, right? But even that, I would say, why? You know, why not just use the language that's built into the Arduino?
I looked at this book and bought it.
Yeah.
When I encountered it, I'm just thinking,
Yeah, don't get
this
me
is a
wrong.
lot of detail.
I happen to love JavaScript personally, but but I wouldn't do it on an Arduino. Right? The languages that you know, there are curly basic languages already built in, so just learning the syntax and programming in its language that it expects. Right? On the other hand, on a Raspberry Pi, you can load up any language you want to. Right? It'll come with C built in, because that's, you know, the GCC compiler is going to be built in automatically. And I think it comes with, gosh, I don't know, it depends on the distribution. I mean, you can get Node.js on there, Java, you know, Pascal, whatever you want to load into it, you can load into a Raspberry Pi. Because the sky's the limit. Once you've got a Linux system running, you know, the sky's the limit, basically.
Well, thank you both for making that clear. Just, I was thinking about buying some Arduino and, you know, to actually work on the mechanical type projects.
Yeah, I would be fascinated as to what the differences are between the different distributions of Linux for the Raspberry Pi. So you've used
Differences.
Yeah, you've used Raspberry, which is, you know, sort of the official version, right? And then you've also just done
Been able to
Debian,
do,
some kind of thing.
there's Linera, Linux, and there's
There's
Debian.
a bunch of them.
I was actually able to run Kali on Raspberry Pi with it.
Wow.
Raspberry, yeah.
That's awesome.
It was funny because my first distribution was Kali because I went to pen testing meetups, and that was the only one I knew. So I did it for
Mark gave me
Did
a
you have a
copy.
Wireshark up on a little card? That's
You gave me a copy of Kali, and I just loaded that diskette from one of our earliest meetings up on a laptop at work the other day. Still, you know, yeah. Yeah, and now, I don't know if this is a distraction or not. I'm wondering on the Raspberry Pi, I don't think it has a BIOS chip, so it doesn't have a boot chip. I think that is on the SD card that you brought. It's one of the tricks of a Raspberry Pi distribution on that SD card, is that I think that there's a very minimal boot hardware on the Raspberry Pi, and it looks at an address on the SD card for the rest of the boot sequence, is what I think. I'm not sure. So it's not just a sort of a standard. The image for a Raspberry Pi has got some tricks in it that are different than, because of the minimal hardware, right? So, and I don't know, Raspberrian is not a minimalist distribution by any means. I mean, it's got a full desktop built into it. You know, once it runs.
designed to be convenient.
Yeah, and it seems like it runs just fine. Most things. I don't know what you would. Again, it's a question of what are you going to do with it? You're going to do robotics, is that true?
Well, that was a little side project. My first project, like I said, I'm setting up a home server. I could have just gotten one of those, for a server, I could have just gotten one of those plug and play like setups, whatever, I forgot what those are called. But what I actually ended up doing, I thought I was being crafty and cheap, but I didn't really actually save that much money. But I bought a 6 terabyte desktop hard drive and another one, and I wanted to do a RAID one. Just a basic, backup in case I lose my data. And so I'm actually, right now, I'm actually having that plugged into the Raspberry Pi, and then the way that I would access my server would be to like SSH from any laptop into the Raspberry Pi. And this is actually also a setup where not only am I trying to learn networking, but I also have a legitimate concern for the cybersecurity aspect of it, so I'm trying to harden my system and as well as setting it up. So I don't want to have that running live while I'm at work. and that someone does a discovery and like finds all that data, which is
So what kind of networking are you interested in? And possibly we could do a future session on networking.
oh sure, yeah. I mean, I'm not an expert at this by any means. I really am just learning. But as a participant of the session, I would be interested in networking with Raspberry Pis. That would be great. After I do this project, like I said, I might get my hands on some Arduinos. Or now that I've listened to you, maybe you convince me that maybe I can take like some just to stick with Raspberry Pi, and that would be enough to
Technology fields are huge overall, right? So you do have to limit yourself and say, I'm going to study this.
Well, maybe we could do a basic IP version 4 session, and just, a little LAN in here and how to subnet and mask.
That would be great. Ideally, I guess specifically, if there was the ideal session for my interest, would be running a server. Setting up a small server. Maybe get yourself one of those like 250 megabyte like hard drives and just see, hey, can we make a server?
Like an install? You want to do an install?
Install like what?
I'm trying to follow your interest here. You want to install the OS or?
You can start with the OS already installed. You have to go through those steps. What would be an interesting session would be just taking already installed and then trying to configure all the networking and then just have.
Okay.
Yeah, that's what I'm learning, which is pretty basic for a lot of people, but I'm just learning. So,
Mark,
anyways.
I have a question. You mentioned a few months back that we could possibly do programming with Linux, right?
I've been trying to find somebody to speak on Python. I'm not the guy, but yeah. If you can find somebody to. I know you requested programming a long time ago.
Yeah, maybe we could do it with Raspberry Pi. I don't know.
Yeah.
What was the name of that device? It was like not a mechanical relay, but it was like something that the Raspberry Pi switched into. It was still TTL.
Well, TTL is a description of an electrical signal level,
Yeah.
right? But and I don't, the Raspberry Pi doesn't have anything like that, right? I just call them boards. There's a whole, if you go, actually Micro Center, and I agree with Dave on that. Micro Center is just fun to go over there and walk down their hobbyist board there and look at it. You'll see what, because, familiarity with what parts are available is a big part.
Yeah.
Part of it, And you'll go down there and you'll say, man, you've got relay boards,
It's been a while since I've actually walked those halls. Since I've started working on my stuff, I think I'll take the visit back there and actually start to recognize things that I've already studied. I'm like, oh, that makes sense. So the driver board is what kind of converts it into TTL.
well, by definition, a driver board is an output board. And then it's what does it drive, right?
Okay, so thank you, John.
I showed you how far I had a plan of what objectives that I wanted to do, and I was very cautious. You can see that I was very tentative.
Yeah.
But I wanted to avoid saying something that I didn't know or was just untrue.
It's okay.
Learn it out. I don't want to come across saying, I think it's this, or I think it's this. That's recklessness or carelessness.
This was good value for me, and everyone's opinion is.
And I'll follow up with a story or two in the next few months. What I can achieve.
What's a really good project for a Raspberry Pi? Just something you can do at home. I guess, something like turning lights on and off is kind of fun. Hook it up to the Wi-Fi. Right?
Yeah, I'd be interested in that.
Yeah.
Is breadboarding projects.
Yeah.
I say, if I get from service, I can give it to my brother and he can have his data, because we're living in times now where there's a lot of interest in keeping control of your data. So.
Right.
You might be doing it with encryption. Come on, don't rely on,
Oh yeah, that too.
The idea that you have a secure boundary is an obsolete concept, right?
Excuse me, Mark.
You should assume
I have
that
a
you're in
question.
public all the time.
Like usual, are you able to send me through my email a certificate of attendance?
Sure, I'll
Et cetera, et cetera.
You have my email,
You
right?
can do all of the inside.
Could you tell me real quick? So I
That's,
can
it's
be
like
sure?
a huge fallacy in the government, but there's a system.
I'll find, I do have
You know,
it.
outside the state.
You have it saved in your
Yeah.
email?
Right, first off, if you
Yeah.
don't have any security controls inside your
I'll
network,
make sure to
then
write down
really
today's.
one of the inside threats.
Topic and date.
Yeah.
It's obvious.
Yeah, thank you.
Right, and then the other thing is, once they penetrate your boundary, your pants are down and you've got no defense.
Right.
Right, so you have to give up on the concept of a secure boundary. And say everything is dangerous everywhere and then take precautions.
Right.
But IT people are lazy and it's hard to take precautions.
That makes sense.
So
They'd
can I
rather
take some
not.
orange juice with me?
There's a.
Take anything you want.
Great,
I
okay.
learned recently, like for air gap systems, that they'll have, this one company, research ways to exfiltrate data just based on having like a security camera focused on like the LED lights that you have on a keyboard, because there's 3 of them, or like caps lock, insert, whatever. So it will create a binary, like it will read the binary, actually send code out, and the camera will pick it up, and they'll be able to read it from the camera.
Well, I went to a conference and these guys, the University of Oregon students were challenged and they broke into a car's computer through the tire air pressure limiter.
Oh,
Right? And they said, within 10 minutes, they were displaying things on the speedometer of a Cadillac.
that's
Right.
scary.
Or make them go 100 miles an hour.
Well, that was the point. In other words, and the other thing that is spooky is medical devices, right? Because the medical device manufacturers like to keep their software proprietary.
And planes.
And planes and things like that. When in security software, the idea of proprietary software is that's a big no-no. It all has to be open source. That's the only standard. In other words, your algorithm is only secure if you can reveal it to the world and they still can't crack it. Right? So all of the encryption algorithms that are used now are open source. And everybody tries to break them, and the ones that basically can't be broken are the ones we use. Because, if you rely on secrecy, in other words, this algorithm, if they knew this equation, then they'd be able to crack our code. You're just being silly. Right? So
I verify that code. That's what I studied, and that's the best practice.
yeah, so that best practice would be extended to things like medical devices. In other words, if you've got the speech I heard was, I'm a big supporter of the Free Software Foundation. Open source, give me this, give me that.
Yeah.
But there was a speaker there, and she said that she had a pacemaker put in her heart, and she was a software engineer. And she said, I asked the physician what operating system the pacemaker ran on. And she said, he took offense. He said, how dare you, basically. And she said, well, I'm not, I'm just curious. This is my field. I just want to know. And that's when she found out that medical device software is all secret.
Okay.
And the problem with that is the FDA has to approve them. Right? So the FDA ends up having a huge problem of certifying these devices as safe to be implanted, which now includes they have no software bugs. Right? And
Well, that certainly makes them accountable.
yeah, and suddenly the manufacturers and the FDA are both saying, don't worry, we've kept this secret from you, but there's probably not any software bugs in there. Right? So there's a big movement, basically, to say, no, we must open source pacemaker software and other things like that, so people can look at it and point at things and say, no, it's a bug right there. That's why, and it's not as if it never happens. Pacemakers in particular, and several that have been taken off the market because the software was bad.
It's funny. A guy I met at a meetup. It might be a Linux project or Raspberry Pi project, but he was trying to create an automated, because his friend has diabetes, or his brother has diabetes, so they have to get the insulin pumped in, and he was trying to create an automated pumping mechanism rather than having like be warned that, oh, you got to do it, your pump is low. He was trying to have a computer control it and pump it, make the decision to do it rather than having react to the warning. Because maybe when he was sleeping, if something happened and he didn't have his insulin or something, maybe he wouldn't be able to get it until he woke up. So it was just trying to make himself safe. But then I was like, man, you got to be careful there.
And trust it, my gosh.
That project, because you don't want that.
Well, I seem to remember having a Raspberry Pi hooked up to my Wi-Fi at home and being able to talk to it from my laptop through the Wi-Fi. So I can't quite remember how I did that. And I had it, and it would turn on red and blue lights. And I had little switches on a website, and I would go red, and stuff like that. So that was my proof of concept, that I could talk to a Raspberry Pi hooked up to my network, right? Which is nice for home automation and subjects like that, but it has a wide open, there are security implications to it, which I don't quite understand. You want to know, if you were really going to make, so for home, I'm just brainstorming, but for home automation applications, you sort of need something that is, you need to answer the security question, in other words, too. Or if it's hardwired into something, I guess that's not a concern. People also do media servers with Raspberry Pis, right? They hook up a big hard disk and serve video files to their TV screen.
Yeah, that's pretty popular. Mine's just, my little server is just going to be catch-all, anything I want to avoid.
Are you doing that just because you like the idea of doing it locally, or what is wrong with the cloud?
It's like, it's like,
You're going to serve files?
I store a lot of things, photos, videos, you want to show your kids when they finally get kids, I just anticipate that throughout my life. I'm going to need terabytes and see more and more data, which hopefully will follow the trend of data storage becoming cheaper. So my whole life, I'm just trying to plan ahead, and maybe the next version will be a RAID 1 with 12 terabytes, and then 24, and then 40 gigs, so on and so forth. As I build up data, and you can have access to it anytime. So.
I know, I'm cloud prejudiced, I guess.
Cloud bridges for the cloud?
For the cloud, yeah.
Really cloud, yeah. Well, it's funny. Like I said, if you have how much data can a person have? Like some people might actually upload a video every day of their lives, YouTuber style, and that will add up to terabytes over the course of several years. So you wonder, can a cloud transmit back?
It's hard to get terabytes. I have over 100 DVDs of digitized home videos now. All right? I don't think I've got a terabyte yet. It's hard to get that much, but it's, and I'm actually trying to think of how to store them up in the cloud now, right? Because it turns out DVDs are not secure long-term storage. Yeah. If you talk to the National Archives, they say that DVDs and CDs have to be replicated every 2 years.
Yeah.
So you need multiple copies, and you have to have a duplication process that is constantly recopying these things.
Yeah.
In fact, they say, they're weird over there in the National Archives. They say if you want to store something for a long time, put it on a piece of paper.
Yeah.
Hard disks are a disaster, DVDs, CDs, not much better. Videotape, forget it. Audio recordings, no. Analog recordings, no. But if you can keep paper dry, it'll last 500 years.
That's ironic. You go back to punch cards.
You're still digging up the Dead Sea Scrolls, right? If that had been a CPU, the data would have been gone a long time ago.
They have the ultimate best example, the longest solution I've heard was millions of years using a crystal, like a silicon or like a quartz crystal that now made that theoretically store data in that.
Yeah. Well, so the point being, if you're going to store data at home and it's really important data, then you need redundant copies, right? And you need to have a way to cycle the hardware.
Yeah.
Right? I can buy that in the cloud.
Yeah.
Right? You know, I've automatically got redundant long-term storage. It actually meets all of the record-keeping requirements.
Yeah, but you're putting your trust in somebody else now because that data center, that cloud belongs to somebody else.
That's true. So there is that. But compared to me setting up an equivalent system at home, man, that's cheap.
Oh, yeah, yeah.
You know, I don't know, like, the internet ever.
I don't even, you know, I'm trying to get away from computers at home. So the Raspberry Pis are fun because they're so special purpose. You know, so if I've got something special I want to do, I can see that. But having a big, strong, general purpose computer at home seems obsolete to me now. You know, why wouldn't I just, you know, spin one up in the cloud somewhere and then shut it back down again when I don't need it?
Sure. Yeah. Something I'll consider, you know. I don't know, I guess I'm just doing this to learn, and, you know, I always think that it's great to have hands-on, and if I have, like I said, I have kids and I want to teach them networking.
Well, there's a lot of people take their antique cars too, you know, it's a lot of fun stuff.
Yeah, teach you the basic components of how I used to, like, if I have kids, I keep going back to this, but teach them 3 things: how a CPU works, how an engine works, and how the brain works.
Okay, there we go.
And that's what runs our world, those 3 things, you know.
So I went to Amazon seminar once, and the CTO of Amazon got up there. This was a long time ago, 2012, I think. And he said, you know, and he had put up this picture. He said, I want to explain the cloud to you and why it's important, because it was a new subject at the time. He put up this picture of an old steam engine. Right?
Yeah.
He said, here's this steam engine. He said, this was an electrical generator used at a brewery in Amsterdam. He said they ran this steam engine to make electricity because it was convenient to use electricity to brew beer, right? He said back then, if you wanted electricity, you had to set up a steam engine like this and turn a generator. And he said that period lasted for about 30 or 40 years. He said every factory had their own electrical generator because that's what you needed to do to make the electricity. And he said, and everybody had a team of 6 to 12 guys that would work 24/7, making sure that the generator was still running, right? And they were a specially skilled team to do that. He said, and then the electrical power utilities came in, and the electricity from them was just as good as the electricity that was made on site, right? And slowly but surely, everybody shut down their old generator, and that those same skill set that was identical, that had been duplicated in every factory, just basically disappeared. A few people at the power company now knew how to run generators.
Yeah.
And that was it, and they delivered power to everyone.
That's a good analogy.
So the analogy was that if you wanted computers and a data center, you had to set up your own. And then you had to hire an IT staff to sit there and run these things 24/7. He said, and then that period started about 1970. He said, and now it's shutting down as we go into the computing utilities, was his analogy. So if your career goal is sysadmin at a data center locally, those jobs are going to become few and far between.
Yeah, that's a good point. Yeah, like I'll have to keep that in mind, and that's definitely not my interpretation. But then, what about like just having a sysadmin skill set in general? Are you saying that will probably, if that trend holds true, that there will be less and less sysadmin jobs because everything will be sort of localized to just a few things?
Yeah. So for instance, Instagram has one person in its production department. All right, it's run entirely in the cloud. You know, all he does is run the cloud contracts. Right? They have developers that write the software. And in order to deploy all that and serve hundreds of millions of people. It requires one person. The other one that was a classic, I don't know if it's applicable now, but you remember Angry Birds game application, right? That went from 0 to 5 million simultaneous users on average in 6 months. And they ran it, you know, it was entirely in the cloud, and they had no production people. You know, they wrote applications and deployed them to the cloud, and it just expanded horizontally forever and ever. Right, and they never had to have someone, you know, buying equipment or patching operating systems or doing anything like that. That was being done, but it was being done in mass by really hardcore professionals at the service that was provided. So there'll still be those jobs, but you know, the sort of average sysadmin running around in different companies and stuff, those jobs are going to largely disappear.
So what would be good to study, in your opinion?
Well, that's a good question. I think development in general is pretty good. Software development is very good. There's also, frankly, the business analysis side of it is really important. In other words, knowing, you know, being able to analyze human problems and translate those into solutions, you know, or be able to talk to the people who can translate those into solutions.
Yeah.
That's a vitally important role. And then the other one, frankly, it depends on what your interests are, but content basically becomes king. So like the designers and the content providers.
Front end.
Yeah, front end gets huge. Now, on the other end, though, right now, if I were going to look at something right now, it's all data analysis, artificial intelligence, and stuff like that. If you can understand that, you don't have to be a specific developer. You know, that's sort of a service on its own.
Well, information security has always been around, at least since the 70s, but now, since I think for the last 15 years, it's morphed into the term cybersecurity, and it's on fire. So anything that's connected seems to be, in my opinion, the advent of IP version 6, and now that everything's connected, brought all this on. So information security is a hot field.
Information security is probably going to remain hot. I agree. But I think that too, right now, it's a little bit inefficient in the way that it's handled. But I think that will remain hot. I agree.
Well, it's a vast sea. You have to specialize in one or two things. And
right. And that can be, you need to have those people to advise, like the developers. I mean, you can't, developers, the programming god is a myth, right? There are no developers who know everything, right? So you need to be able to, in a team, you have to be able to say, oh, I'm writing this program, and then the cybersecurity expert has to say, well, I'm okay, but you have to follow these protocols, otherwise, you know, I can't certify it. That's something we can, you know, put in somebody's heart.
well, the nirvana would be if the two were just merged. I mean, the developer has InfoSec in mind. That it's, you know, it's just baked in. You don't bolt it in secondhand.
No, I agree, yeah. But even that, I mean, you have, amongst developers, you have back-end specialists, front-end specialists. You'll have security specialists, you know, you'll have AI specialists.
Yeah.
Right?
Yeah. I mean, while I was in an interview, because I'm really just starting out, I got to learn Python. I got to learn, I'm trying to learn, I got to learn. So anyways, going back to the sysadmin, I've talked to a sysadmin, which, based on what you're saying, I'm like, I've never really wanted to get into that, but now that I've heard that, I'm kind of steering away from it.
Now I'm nervous. I didn't know it.
Well,
intended more as a discussion than advice to a young person.
Oh no, well it was both, but it's
something to think about.
I'm here for knowledge, so and to listen to people who got experience. But the sysadmin said, you worked with one language for scripting, so he chose like say Python, and then one language for I think it was you would use PowerShell for doing the administration, and then one language to pull data to and from serverless SQL. And so he's got that skill set, and that's how he does sysadmin. But then on top of that, you want to add one language for development, like C. Now, I did an interview where they were looking for an automated software tester, not a manual one, because I've done manual software, but automated, which means Selenium, and then you use Python scripting in Selenium. Well, I didn't. I failed that interview because I didn't have that skill set. But just for me, like I wouldn't go straight into development, but just learning the scripting language is a great way to start, because with scripting, you can be a part of the process because you need to software test in the software development process. And then from there, I can learn to do actual development. So there is a ladder that I can have.
Well, I heard a guy a long time ago who said, you got to learn a new language every year.
Yeah.
And it's in your career in software, you should just be learning a new language every year.
Sure.
And over the last 10 years, I've been close to that. When I started out as a Java programmer, I never used Java now. You know, I'm looking out into the future, and there's a language called Rust that has me turned on. You know, I'm thinking Rust is, wow, that looks pretty good.
Why is it called Rust? It's the current, right?
But it's actually it's a very interesting language to learn. It might be I think it's going to be a hot language to know.
Rust.
But see, that's the other thing. So I learned Python. I had a Python phase, you know, and I ended up doing a whole bunch of stuff in JavaScript. It turns out forever and ever. I actually love JavaScript a lot, but Rust looks good. I did Erlang for a while.
Oh, yeah.
Yeah. Erlang was cool, man. I wish there were jobs with Erlang. If I could spend my life programming in Python and Erlang, that would be so fun, because it just felt good to write those languages. Right? Java, on the other hand, it's funny, there's so many Java jobs out there, and that is the ugliest, most verbose language I've ever seen. Just hate it.
I think the whole concept is wrong, but I'm just one guy.
Well, you know, you got a good point there. Well, there was a time when I was a huge Java supporter, but in retrospect, you know, maybe it wasn't that smart. You know, and God bless C and C++, man, they just survive forever and ever. It just keeps going. And there are fields where that is what you have to know.
The low-level languages don't seem to change as fast as the high levels.
Yeah, well, yeah, that's true. C is pretty good. You know, if you were going to do like game development, you almost have to learn C# right now. You know, and that's attractive just because games are fun.
So people with game development, there are people out there that find it fun to do assembly, choose to optimize certain parts of the game.
Well, yeah. And there's also, you know, there's native programming for browsers. In other words, people are saying, let's skip all this HTML and JavaScript and program down at basically browser assembly level, you know. So there's a bunch of subgenres like that.
Let's get in here. Just follow on that. This is the only book that I have found that discusses HTML, CSS, and JavaScript all together and how they fit together. I've gone to some meetups up in the Reston, and there have been guys talking about JavaScript and the code that they've written. And it's all complicated, and it's mixed in with HTML and CSS, which is a concept, you know, for expressing order and organization. It conflicts, and I'm not sure why JavaScript programmers go for that obfuscation or mixing up of HTML, CSS, and JavaScript together. I mean, there's lots of parts of it that it's all split up, and it's like, really? They pay you money to throw in all these little phrases and paragraphs in those three languages together, and apparently they do.
Well, there's an argument. React is sort of the JavaScript purist web framework, you know, in that, and because they're packaging it up into web components, right? And I think the logic is that why would I learn these three different categories when I can do it all in JavaScript, right? So they tend to write components. So for instance, you can write entirely new widgets now as components in JavaScript, right? So if I'm going to do that anyway, then why don't I just do my styling and my formatting and everything in JavaScript? So I tend to agree with you. If you're a designer, suddenly that's not very fun. It's very difficult for them to understand, so they need to be able to, you know, discuss their design with these JavaScript purists and then get them to do it. But the React is very modular. It's a very strong platform. There's some things that support it. But yeah, I agree with you. I think the people that go, we're going to do the web with nothing but JavaScript, I think they've gone off the deep end a little. I think, although the idea of web components, that is the future. Everybody does that now. So Angular, React, Vue.js, just go down the list. All of the front-end frameworks use the concept of making components. And so those are JavaScript modules. That then depending, so for instance, I'm sorry, I distract on this, but Vue.js is a framework that they use a lot of HTML and a lot of CSS. So they use the HTML to structure the page, they use the CSS to style the page, and then they use JavaScript for functionality, but they wrap it all up into JavaScript objects and then you load it up to the page.
You're the only one who's explaining this to me. I go to the bookstores and it's like, what am I really looking
Well,
at?
that's, no,
How long is it going to take?
human brains are limited. You've got to keep things straight and make them simple. You know, you've got to narrow down your sample and learn this one field and just run with it. But I've used several of the front-end frameworks over time. And I kind of wish I'd studied React at one time just because there's so many jobs for React people.
But when you say framework, you're saying, are you saying for web development is something that just
Yeah, exactly. Well, there's frameworks for different things. There are frameworks for server side. You know, there are frameworks for the front end.
Okay.
All right, and then people also talk about stacks, which are combinations of frameworks and things that you're in order to create an entire product.
Yeah.
Right, so like a LAMP stack typically was what was that? Linux, Apache, MySQL, and PHP. Right, that was a LAMP stack. You could make a complete web application with a LAMP stack, and then there are. Right now, there's a bunch of different stacks. There are Python-based stacks. You know, there are a couple of PHP ones out there. Things like that.
That's what they call full stack development.
Full stack developer. If somebody asks me what I am, I say I'm a full stack cloud developer. Right? Because I don't do hardware. But that also means when I hear somebody say full stack, that means okay, so you're a jack of all trades and a master of none, basically. Is also another way to put that. Right? So it's nice to be able to concentrate on one thing, have fun with it, and really know it in detail, as opposed to I know just enough about everything to assemble something together. But so learn a language, because once you learn one or two of them, then suddenly learning a new one it gets really easy.
Yeah. That's my understanding.
Well,
So-
then you've got the object-oriented camp and the,
Well, they're object-oriented, they're functional, so you learn an object-oriented one, you learn a functional language, and pretty soon...
to me, they're different animals.
Yeah, they're different animals, but they've got loops, they've got control structures, you know. Pretty soon you say, well, you know, like for instance, I get confused all the time as to how to write for loops, because I've done for loops in Java, Python, and JavaScript, right? And I forget the exact syntax that I'm supposed to be using for whatever language I'm in. And so what do? I Google it, and I say JavaScript for loop. Oh yeah, that's right.
Or that is to say that a framework would correct you because it will detect your...
Well, that's another, you know, your development environment is another question, right? So lately I've been using VS Code for everything, which surprises me because I'm not much of a Microsoft fan, but that's a really good development environment. VS Code, yeah.
I've heard of that. I'll look for it.
Oh man, that's fantastic. And very flexible. So it's got a text editor, it's got a terminal window, it's got, you know, all kinds of code plugins that are available for it. And it's also available for all different platforms. So at work I've got a Linux machine, a Windows 10 machine, and a Mac. And I run VS Code on all of them.
Wow.
Right? And I can throw files back and forth between the systems without any problems. But for a while, before I adopted VS Code, I had gone sort of a primitive purist all right, where I would use a terminal window, a text editor, and a browser. So any text editor, any terminal window, or bash terminal window in a browser, so that I had no dependency or configuration issues. Because back in my Java days, I would use Eclipse as the development environment. And I spent half my time making sure my Eclipse configuration was correct. Right? So I said, I hate that. And then I went to IntelliJ for something. I think I was doing Python then, and a few other things. Actually, I'm not sure what I was doing at the time. But I ended up saying, if I can do the command line in the terminal, have a text editor to write files, and then a browser window to look at the results, then I've got enough to do development work. Right? Yeah. And it was also kind of macho. I mean, amongst other programmers, just use a terminal window. But it turns out that VS Code is just really good. It's very close to that. Yeah. It's a really good system, I must admit. There it is. Yeah, it's free. I mean, you download it for free. If you're on Windows, you have to add a plug-in to get a bash terminal, because otherwise it brings up PowerShell.
So this you can do pretty much almost
any language you want to do, yes, in that environment by itself. So I'm strongly advised right now. It's the best. And then you can run Python or JavaScript or C or .NET.
Wow.
You know, whatever you want to develop, you can develop in that environment. They've got plugins for everything. Yeah. We've got plugins for the frameworks. You know, so I started doing this because I was going to a Vue.js meetup to do front-end work. And the guy who was running the meetup was using this, right? And he said, well, what do you use? And I said, well, I use a terminal window and a browser. And he said, well, okay, you know, respect, you know, but maybe you'd like to make your life easier and use this. So I tried it. And I had to admit to him later, he was absolutely right. But it had Vue.js plugins. So even the framework I was using, it would correct the grammar in the JavaScript per the specific framework I was using. You know, and make suggestions about what to do. Yeah. So it's a hot idea. So you got to get the development run, and then how are you going to, what's the rest of your stack going to look like? Yeah. Or whatever. If you're going to do development work, I mean, you can get a job in any one of those areas. Right? Learn that area.
Yeah. You know, so like I said, that was my trajectory. Started off maybe with the software testing path, and move into actual development.
Automated software testing, that's a good field.
Yeah.
That's a really good field.
No shortage of work in that.
No shortage of work whatsoever. In fact, I've got a good friend who is, I think he's close to $200K a year right now. He's all 32 years old.
Those are the numbers that I like to hear.
Yeah.
I haven't even begun to hear those
He's a Node.js programmer who is an expert on automated testing, primarily, and does back-end development work. Yeah. But he doesn't do C, he doesn't do anything else, he does JavaScript. Yeah. But he's got that automated testing thing. And so, are you familiar with like versioning control and stuff? Git and that sort of stuff?
Yes, actually, as a matter of fact, I familiarized myself with the group, this Linux user group.
Okay, so, real software is not made by individuals, it's made by huge teams, right? So they have to be able to work together as a huge team. And so your version control is important, but also the build chain, the testing build chain is really important. So you've got a committee of people who are in charge of basically approving what's happening. Right? You've got small teams or individuals that are working on a little snippet of code somewhere. And they say, they make a pull request to the team, right? And then other people review that code. And he's supposed to have already tested it, right? And you've got a separate test group. So in some outfits, they'll have tests. They'll run thousands of tests on any new piece of software. It's got to be automated, because otherwise you can't do it all, right? And so he'll run it against those tests, and it has to pass those tests before he can submit it to the group, and then the approval committee or some kind of governance of the project. We'll look at it and decide whether or not to put it into, you know, in a bleeding edge distribution or where. And eventually it gets, you know, goes through the Nike build and is up into production, right? It's a huge enterprise to get it done right, and that's all more of an engineering function than computer science. But the idea of, well, when you do test-driven development, TDD, is you know, you establish a feature or a function that you want to have accomplished, and then you design a test to test for it first before you do any code. And so the test will then fail, right? So you have to first get a test that tests for the feature and fails. And then you program just enough to get that test to pass. And then you're done.
Interesting.
All right?
Yeah.
So that's called test-driven development. All right? So then that test then becomes part of the testing suite, right? And then somebody says, it's great that your software you know, submits the timestamp on my application. But, you know, when I did it on leap year, it didn't work.
Yeah.
All right, so then you design the first thing you do is say, wow, you duplicate that error. You say, yes, it doesn't work on leap year. And then you develop a test first for detecting leap year. And then you code until you can pass the test that for leap year. And that's something almost nobody does, but that's sort of an ideal. That's test-driven development by ideal. And then, whenever you make some change in other parts of the software, basically it has to pass all of the existing tests before it gets ready.
I see. So just to verify, so I get this solidified in my brain, you have software that lacks that feature.
Okay.
You develop a test to, what would be the appropriate test, the experiment, like a scientist, to detect positively that feature exists and that performs. You put it on the software, it fails. Then you code until you pass that test.
Right.
That's
Like an example might be, everything seems to be running great, but when this number, which happens to be longer than the long int of the software you used to develop it, it fails. Right? So you say, oh gosh, we have to develop a test for when really large numbers are in. Right? So, you know, that's a very basic concept, right? But then all of those have little qualifiers, you know, like what is a good definition of a feature to be tested, and, you know, it goes on and on as to how to do that well. But the concept, you got the concept down.
Yeah.
So you might, if you started a new project with a Raspberry Pi, you know, your first test might be lights up, right? And then you would work on it long enough to get it to light up. Say, great, now I want characters, right? Now I'm going to detect characters by watching this display screen, right? Something like that. And that would be the idea of test-driven development. And we march through the project, basically, going one step after another.
So I guess that's an idea of rather than taking software that is not optimized, a finished product that is not optimized, it's like you're kind of optimizing while you build it because you just want to keep it minimum. You don't want to have to get all this fluff.
Well, yeah, you don't want your development teams because again, you're talking about teams sometimes, you know, hundreds of people, right? You don't want these teams running wild and amok. Right? They've all been given their little task. And they've been given a contract. So even with object-oriented programming or web objects and things like that, let's say that I'm working with you know, National Geographic on their website, and they would like to have a small widget, you know, that that puts mustaches on tigers or something, you know, like that. Right? So we've got a designer, we've got all these different teams, right? Well, we have to first have basically a contract, a specification as to what our widget is going to receive inside of the web browser, and then, and then what it's supposed to do or output back or whatever. So maybe we're developing the JavaScript that adds the mustache to the widget, not the widget itself, right? So we say, okay, we get an image of a tiger, and then we're supposed to give back the coordinates of the mustache and the mustache icon. You know, some very basic contract, you know, and then our team works with a set of standard tiger images, you know, or coordinates or whatever it is, and we develop tests to see if we can, you know, kick back the correct results, right? And we really don't have a picture of all of the rest of what's going on, but we comply with that, and then it passes its tests. So then you have, then you have unit testing, right? And unit testing implies the individual modules. So you've got a contract on this module. Let's say that it converts Unix epoch timestamps into human readable data, which is a fairly standard module, actually, right? And we've got a unit test that runs a bunch of test examples and expects certain results. We say it passes the unit test. And then later you have, you know, build and integration testing, where, you know, all these things are put together and the entire application is supposed to be tested to see if the final functionality actually works. But before you do that, all the individual units have to pass their own unit tests, their own separate specification. So you get, well, JavaScript is different in that it's so open source, actually. There's, you know, you go to the NPM repository, there are 10,000 different modules available for download. Some of them tested, some of them not, but theoretically they've all been tested, and they provide specific functionality. Yeah. So you've got like a, you know, Excel to CSV converter module. You download that module, add it to your program, and you literally import it with an import statement, right? And you never look at the code, right? You've got a API, you know, application programming interface specification, and you say, okay, you know, so when I use this thing, it's got a command that says convert, and then I give it the path to the file, and I give it a name for the output file, and then it converts my Excel file into a CSV, right? And that's what it gives me back, and then you can just add that into your program. Well, when I do a program in a framework like Vue.js, first off, Vue.js are modules like that have been tested, and they have sub-modules that have been tested, and I also import other modules that do other things. One of the programs I developed earlier this spring, I was dumbfounded because you do a download portion in the build cycle. I was downloading 1,800 modules, right? I hadn't tested one of these modules, right? But they all seem to work.
Yeah.
But anyway, that was a very long diatribe. I'm sorry, but the testing is a good field.
Yeah.
You know, it's kind of something that it's not romantic or something like that, but man, inside the software world, right? Not development world, automated testing, that would get your job.
It does sound like the clients are interested in this process.
Do you need a certification for Selenium?
No. I mean, there might be some out there, but right now there's no certificate. I don't think it depends on the commercial level.
Would you say Selenium is like the most popular software? Give me some names. Did you have any? I could read up on skills.
Well, Selenium, I think, isn't Selenium sort of an integration tester? I mean, there are two, again, it's the big division is unit versus integration testing. So the program I've been using lately is something called Jest, G-E-S-T, which is not, it's like second or third rank. It's not the most popular, but it's very simple to use. And then there's one called, what is that called? Geez, I lose my vocabulary as I get older. But Selenium, I believe, is more of an integration tester than a unit tester. I could be wrong. You know, but there are programs, for instance, it's not Selenium. I'm sorry, I forgot.
You probably think of it 6 hours or
something like that. But there are integration testers for front ends, for instance, that take screenshots of the output of your website as it runs through simulating punching buttons. And then it will run through the test and compare screenshot to screenshot, even, you know, to totally replace human testers, if you will. You know, so you need to, you need to learn, the programming languages, but then you have to get into the individual applications in what you're doing, right? Or the framework or whatever it is.
Yeah.
Something like a Vue.js framework, it comes with a suggested testing suite. You can run tests right inside a Vue.js framework. React similarly, Angular also. React right now is the popular front-end framework. Vue.js is an up-and-comer. It's kind of everybody thinks it's fun. I think Angular is sort of peaked. Linux, though, you say you just got a Linux certification. That's solid. Man. That works in the cloud. That works everywhere.
I think so, yeah, because I was thinking to myself, oh, with Linux, I'll just be able to do sysadmin theory.
Well,
with Linux, you're saying that.
No, you got to know about Linux so that you can spin stuff up in the cloud. Because the cloud basically runs on Linux.
Mhm.
Or Microsoft would love to have more influence in the cloud, but the cloud is Linux.
That's the, I don't know, you're on the Novolog mailing list, I assume.
Yeah.
There's an argument going back and forth right now about there are no more proprietary Unixes. It's all Linux.
Yeah.
Everything became Linux. And I mean, there are some HPUX out there, some AIX floating around, but it's less than 1%. Even Windows is headed that way.
Yeah, that's true. Yeah. They start all giving
From
up.
Steve Ballmer now to Satin AI, you're opening up to Linux. With the purchase of Red Hat now as a division of IBM. Stop.
Well, that's IBM bought their way into the cloud market with that one, with the purchase of Red Hat.
Yeah, these cloud places are just crazy.
What about Amazon?
Amazon, it's the big clouds are Amazon and Google, period. Microsoft is keeping their foot in the door with their Azure cloud. But man, they were way behind.
I heard Google people are not, Google's becoming less and less popular, but that's just what I heard.
No,
I don't know.
well, first off, what is Google would be a good question, all right? Google lays more backbone, more internet backbone than any other entity on Earth.
Yeah.
When they had that big earthquake that knocked out the nuclear reactor in Japan, it cut all the public cables to Japan, and Google voluntarily picked up the entire internet traffic of the country of Japan in their spare capacity going across the Pacific.
Did not know that.
They've got so much. It's ridiculous.
Yeah, and Google is investing in the next county up, just north of Fairfax in Loudoun County. It's southern around Leesburg, that there are those.
Yeah. So when you say cloud, so they're doing internet infrastructure, right? And then the cloud is basically applications, data centers and applications above that, right? So it's almost a separate business activity.
It's funny you say that because there's a lot of places like in Philadelphia, which are like small little towns, you wouldn't really be like tourists there. Yet these tech companies are making decisions to put all like data centers, and you end up having like just a conglomerate of data centers like end up in like this small town like in Philadelphia. I've got like one of them or something like that, which increases all of a sudden its revenue. And because of these tech companies, they create like an economic growth in that area. And then on top of that economic growth, that leads to like other attractions, which creates more tourism. And then all of a sudden you learn that this town is popular.
I think it's escaping us. Maybe not you so much, but the other three of us are considerably older.
Yeah.
And it's hard to imagine the scale of these things. For instance, the cloud data centers now consume 5% of all the electricity generated in the United States.
Yeah.
It's not air conditioning, it's not that. It's running cloud computers in massive data centers. Is that much electricity? In fact, that's the other thing that this guy from Amazon said. He said, do you know what happens if the power goes out at one of these data centers? He said, the first thing that happens is you get on the phone and start ordering diesel fuel. He said, you've got to have.
We've come full circle to your
Yeah, he
earlier
said, "You've got to-" He
conversation.
said, I've got 8 hours of diesel fuel to run my generators on site. And he said, I've got to get on the phone and get a line of trucks coming into that data center to keep those generators running. He said, that's the most important thing.
Yeah, it's pretty strict too.
Well, and they have,
Top will say,
they have-
hey, if you don't have this system up, still running in 2 hours, Frank, two hours or something, you lose your job. Get someone else. You know, it's really dramatic.
Yeah,
It's not an easy place to work with a crisis situation.
yeah, it's a big thing.
That's the thing, like, I back to my point, like, who would have thought, not West Virginia, but like Northwestern Virginia of all places would be like a place that would just suddenly get this boom of economic growth because they were putting their data centers there. It's like, what? That doesn't even make sense.
there's
You know?
some
It used to be farmland.
Yeah, that's out there and just outside the nuclear radius from DC, one of the big backbones is running through there. And they like to put those things on where power is cheap and where they have, good connections to
Yeah,
the internet. So,
yeah. So that's pretty
well, I learned Linux, learned Python, and then learn another language.
Yep,
And
that's
then you've got to learn something for a job, right?
Yep, that's my plan. Definitely going to be taking a few classes. I got my TA with my job at work from Salem.
Very good.
So so I'm definitely trying to make use of those benefits. And
Is it up at Tyson's?
it's, my home office, they got me based down in Stafford, but the Tyson's headquarters.
Yeah.
And it's a great office. They really, you don't get paid as much as booze, but they treat their employees really well with benefits. And so I'm just trying to make use of that, and I'm going to be taking classes this year and just trying to learn those things. That's my goal. But thank you so much for all this discussion. It's been really great way to wake up in the morning.
Well, so thanks again, John.
Yeah.
And we've got something on the books for November. Zach, also from Novalug, is going to come down and talk to us about Chromebooks and F-Droids. And I'm putting something together for October. I think I'm going to do part 2 of Wireshark. Drill down into some specifics. Maybe do some wireless and some web pen testing. All right, thanks again.
Yeah, our original networking class actually got me started. I took another networking class last month. And because I'd been here, it was advantageous to have had some networking knowledge before I got into it. Because I used to think, network just existed. Why would I care about that? I'm a developer. And then,
Well, that's like who needs to hunt or kill cows because there's a supermarket down the road?
right, yeah, exactly.